Assalamu alaikum all. Can you hear my voice? Okay, so in continuation to our face-to-face lecture, we were discussing about chapter number 1 and chapter number 2. This is just an overview that we have already discussed in our computer networks subject. So in continuation to that, today we will discuss about some information network and technology review techniques. Now in continuation to this, these are the objectives. We will discuss about some network topologies that are there in LAN and WAN networks. We will discuss about bus, ring, star and hybrid hub. And we will see mesh and tree topology also. Then we will discuss about different types of Ethernet. We have already discussed it, but still we will discuss so that it will be a revision for you. And then we will see virtual local area network and token ring. FDDI, that is fiber distributed data interface. Then different network components like bridges, routers, gateways, and different types of switching techniques, circuit switching and packet switching, and transmission technologies. So first of all, you can see this is the basic LAN topology. Here DTE, this DTE stands for data terminal equipment. So here we have an Ethernet and these are the data terminal equipments. This is the bus topology and this is the ring topology. And you know that the term physical topology refers to the way in which a network is laid out physically. So two or more devices connect to a link. Two or more links form a topology. The topology of a network is the geometric representation of the relationships of all the links and linking devices, usually called nodes, to one another. So you can think of this DTE, that is data terminal equipment, as a node. So this is the bus topology, and you know that a bus topology is basically a multi-point topology. There is one long cable which acts as a backbone to link all the devices in a network. So nodes are connected to the bus cable by drop lines and taps. And you know that drop line is a connection which is running between the device and the main cable. And a tap is a connector that either splices into the main cable or the shielding of our cable to create a contact with the metallic core. So as a signal travels along the backbone, some of its energy is transmitted into heat. Therefore, it becomes weaker and weaker as it has to travel farther and farther. So for this reason, there is a limit on the number of taps a bus can support and on the distance between those taps. Now next, here we have ring topology. In ring topology, each device has a dedicated point-to-point connection only with the two devices on either side of it. So a signal is passed along the ring in one direction from device to device until it reaches its destination. So each device in the ring incorporates a repeater, and when a device receives a signal which is intended for another device, its repeater regenerates the bits and passes them along. So a ring is relatively easy to install and reconfigure. Each device is linked only to its immediate neighbors, either physically or logically. So to add or delete a device requires changing only two connections. So here the only constraint are media and traffic considerations. So maximum ring length and the number of devices. And in addition to this, fault isolation is specified, and generally in a ring, a signal is circulating at all times. So if one device does not receive a signal within a specified period, it can issue an alarm, and the alarm alerts the network operator to the problem and its location. Now next we have hub configuration. Hub is a LAN in a box, basically. Now you know that hub is a device that operates only in the physical layer. So signals that carry information within a network can travel a fixed distance before attenuation endangers the integrity of the data. So it is a connecting device, and you know that connecting device connects hosts together to make a network, or to connect networks together to make an internet. So connecting devices can operate in different layers of the internet model, and we will discuss them one by one, inshallah. Already we have discussed in computer networks about hubs, link layers, switches and routers, but if it will come, we will discuss it again. This is wireless local area network, and it is based on IEEE 802.11. So wireless LAN is also called IEEE 802.11. These are some of the standards and amendments that have to be followed by different networks. These are the WAN topologies, where we have mesh topology and tree topology. In mesh topology, we know that every device has a dedicated point-to-point link to every other device. Here the term dedicated means that the link carries traffic only between the two devices it connects. So a fully connected mesh network has n-1/2 physical channels to link n devices. Now this mesh topology has several advantages over other network topologies. The first advantage is the use of dedicated links basically guarantees that each connection can carry its own data load, and therefore it eliminates the traffic problems that can occur when links must be shared by multiple devices. Second advantage is it is robust in nature. It means that if one link becomes unstable, it does not incapacitate the entire system. Third advantage is the privacy and security. Now when every message travels along a dedicated line, only the intended recipient sees it. So physical boundaries prevent other users from gaining access to messages. Now the disadvantage of this topology is that it is related to the amount of cabling and the number of input-output ports required. Because every device must be connected to every other device, installation and reconnection is difficult. And the second disadvantage is the bulk of wiring. Now, because of bulk of wiring can be greater than the available space. So the problem is that of accommodation. And finally, the hardware required to connect each link, that is input-output port and cable, and it is relatively expensive as compared to other topologies. So for these reasons, a mesh topology is usually implemented in a limited fashion. For example, as a backbone connecting the main computer of a hybrid network that can include several other topologies. And here we have the tree topology, which has the structure of a tree. It has a hierarchical nature where we have a root node, then we have branches, and then we have sub-branches. So this ring topology, here we have each device which has a dedicated point-to-point connection only with the two other devices. And it is also called broadband feeder network. Now next we have Ethernet. Now if you remember Ethernet that we have discussed, we have seen that it has two major layers. That is the logical link control LLC and the media access control sublayer, that is MAC sublayer. So this table shows Ethernet LAN topology limits. We have 10 base 2, 10 base 5, 10 base T, and 10 base F. So base stands for baseband transmission, and because it is 2, so that means this is thin coaxial. The length is 200 meters, and since it is 5, so that means it is the segment length is 500 meters, and we are talking about thick coaxial cable. And this is IEEE 802.3 standard. 10 stands for 10 megabits per second, that is the data rate. This is the fast Ethernet, and it is also called 100 base T4. It is compatible with 10 base T. And category Cat 5e, Cat stands for category. So these cables we are using in fast Ethernet, that is category 5e and category 6 cables. Now next is the Gigabit Ethernet. Now the recent need for an even higher data rate resulted in the design of Gigabit Ethernet, and it is 1000 Mbps, 1000 megabits per second. So here we have MAC sublayer. The whole idea is the evolution of Ethernet was to keep the MAC sublayer untouched. So when it came to sending at a 1 gigabit per second rate, this was no longer possible. Now the access method that we are using in Gigabit Ethernet has two distinctive approaches for medium access: half duplex using CSMA-CD or full duplex with no need for CSMA-CD. So although the half duplex approach is very interesting, it is complicated, and it is not used today. And in full duplex approach, there is no need for CSMA-CD. If you remember CSMA-CD, it stands for Carrier Sense Multiple Access with Collision Detection. So almost all implementations of Gigabit Ethernet follow the full duplex approach. Here, the packet size is 512 bytes. The minimum frame size is 64 bytes. And packet burst with no ideal time between frames increases efficiency. Now we have switched Ethernet, where we have a switched hub in between, and we have number of DTEs. DTEs, as I have told you, it stands for data terminal equipment. So here, a layer 2 switch basically is an N-port bridge with additional sophistication that allows faster handling of the packets. So the evolution from a bridged Ethernet to a switched Ethernet was a big step that opened the way to an even faster Ethernet. So before switched Ethernet, we were using bridged Ethernet. And this is faster as compared to bridge, because the idea of a bridged LAN can be extended to a switched LAN. Instead of having 2 or 4 networks, why not have N networks, where N is the number of stations on the LAN. So if we can have a multiple port bridge, then we can have N port switch also. So in this way, the bandwidth is shared only between the station and the switch. So the data rate here is 5 Mbps for each. So in addition, the collision domain is divided into N domains. So here the throughput is maximum. Throughput is number of jobs executed per unit time. So it has maximum throughput. This is the client server configuration using switched hub in between. Hub, as you know, it is a device that operates only in the physical layer. So signals that carry information within a network can travel a fixed distance before attenuation endangers the integrity of the data. So here the data rate is 10 megabits per second for each workstation. This is the virtual LAN, or we can say VLANs. Here we have switched hubs, which enables establishing virtual LANs and permits switching stations between LANs without physical moving of equipment. And it removes VLAN via switch offered by service provider. So basically, a station is considered part of a LAN if it physically belongs to that LAN. So the criteria of membership is basically geographic. Now, what happens if we need a virtual connection between two stations belonging to two different physical local area networks? So we can say that it is basically virtual local area network as a local area network configured by software, not by physical wiring, because it is not physically present. So here we have 5 data terminal equipments. Now this VLAN groups the stations belonging to one or more physical local area networks into broadcast domains. Now the stations in a virtual local area network communicate with one another as though they belong to a physical segment, one physical segment. So VLAN technology even allows the grouping of stations connected to different switches in a VLAN. So here we have two VLANs, as you can see. Local area network is supported with the switches and with two virtual local area networks. It acts as a backbone. This is the token ring, which is adopted by IBM, that is International Business Machine. It is based on IEEE 802.5 standard. The data rate of token ring local area network is 4 megabits per second and 16 megabits per second. And here we have single LANs also and dual token ring LANs also. This is the dual ring local area network. Now we have FDDI. FDDI stands for Fiber Distributed Data Interface. It uses fiber optics medium switch, bridge, router, and we have one more thing, that is repeater. Repeater receives a signal, and before it becomes too weak or corrupted, it regenerates and retimes the original bit pattern. So the repeater basically sends the refreshed signal, and in the past when Ethernet local area networks were using bus topology, a repeater was used to connect two segments of a LAN to overcome the length restriction of the coaxial cable. So today, Ethernet local area networks basically use star topology, and in a star topology, a repeater is a multi-port device, and it is also called hub, that can be used to serve as the connecting point, and at the same time it functions as a repeater. Now here we have a switch, and it is also called sometimes link layer switch. It operates in both the physical and the data link layer. As a physical layer device, it regenerates the signal it receives. As a link layer device, the link layer switch can check the MAC addresses. MAC stands for Media Access Control. It includes both source and destination, which is contained in a frame. Then we have bridges and also routers. So these are the basic network node components. These figures shows the network components. We have a dial-up network, the external network. So different types of external networks are there, and in between we have different network node components, which includes half router, switched hub, remote bridge, then bridge, gateway, etc. This is the hub, which is a platform, and its function dependent on what is housed, that is LAN, switched LAN or bridge. This is the stacked hub. So hub ports can be scaled up using stacked hubs. So stacked hubs basically extend the backplane and it is connected as a chain. This is the bridge. There are two types of bridges, local bridge and remote bridge. In local bridge, again, we have three categories: simple, multi-port, and multi-port multi-protocol. This is the router. It operates at the network layer. It routes the packets between nodes of similar network protocols. So what happens? Whenever the routers are used, routing table has to be created. So routing table, they are used to route the data packets between networks. Then DLC. DLC stands for data link control. And physical layers could be different under the same common network layer protocol. So if you remember, we have used spanning tree and different ways by which we create the routing table. Now this is the gateway. It is a router connecting two networks with dissimilar network protocols. It performs protocol conversion at the network layer, and protocol converter does the conversion at the application layer. So this is the basic difference between the protocol converter and the gateway. This is the tunneling approach. It is the transmission of packets by encapsulation. So as you know, when the data packet is moved from one layer to the next, it is basically encapsulated by using a header. So every time as it moves from one layer to the next, it is encapsulated, that is, a header is added. So here the packets are encapsulated and it is transmitted through the network, one after another. So the mode of transmission is serial transmission. This figure shows half bridge configuration, where we have router, we have bridge, and we have Ethernet. So this half bridge, which is also called half router, is point-to-point communication. It uses PPP protocol. PPP is point-to-point protocol. It helps low-end users to communicate with ISP, that is Internet Service Provider, on dial-up link, saving the expense of dedicated link. Router encapsulates packets in PPP frames and put serial outputs to the bridge and vice versa. This shows the switched network, the datagram configuration, and the virtual circuit configuration. So we have different switching techniques basically. We have circuit switch, we have packet switch techniques. So this is the transmission technology where we have different transmission mediums for the transmission of signals. So we have UTP, that is unshielded twisted pair, coax, that is coaxial cable, fiber optic cable, and we have different wireless media also by which the signal is transmitted. So the transmission technology basically has two categories, guided media and unguided media. So in guided media we have twisted pair cable, we have coaxial cable. In twisted pair we have UTP and STP, shielded twisted pair and unshielded twisted pair, and also fiber optic cables comes under the category of guided media. In unguided media we have wireless transmission. These are the different transmission modes. This is multi-protocol label switching. It combines IP and the performance of ATM, asynchronous transmission mode. This is the SONET transmission. SONET stands for Synchronous Optical Network, and it is based on synchronous digital hierarchy, that is SDH. This figure shows synchronous digital hierarchy. This is DWDM, that is dense wavelength division multiplexing. So it is a part of multiplexing technique. Multiple wavelength carrier can be configured for multiple protocol transmission, and it is similar to FDM at lower frequencies. FDM stands for Frequency Division Multiplexing. FDM, Frequency Division Multiplexing. This figure shows the broadband services network. It has integrated services of voice, video, and data. It has broadband services. It includes SONET network in SDH. The access technology can be through wired media or wireless media. So with this, we came to an end. If you have any question, any query, please ask. Yes, regarding your assignment, as I told you earlier, you have to do week 2 assignment, but don't submit it. Keep it with you. I will inform you, inshallah, by the next week when you have to submit it. Because so far I haven't came to know about the concerned person. So once I'll come to know about the coordinator of this course, I'll let you know when you have to submit your assignment. But do it and keep it with you.